So what happens if you're trying to predict some value that is based on more than one other attribute? Let's say that the height of people not only depends on their weight, but also on their genetics or some other things that might factor into it. Well, that's where multivariate analysis comes in. You can actually build models, regression models, that take more than one factor into account at once. And it's actually pretty easy to do with Python, so let's dive in. Next, let's talk about multivariate regression, which is a little bit more complicated. So the idea of multivariate regression is, what if there's more than one factor that influences the thing you're trying to predict? So in our previous examples, when we looked at linear regression, we talked about predicting people's heights based on their weight, for example. And we assumed that the weight was the only thing that influenced their height, but maybe there's other factors too. Or we looked at the effect of page speed on purchase amounts. Maybe there's more that influences purchase amounts than just page speed, and we want to find how these different factors all combine together to influence that value. So that's where multivariate regression comes in. So the example we're going to look at is, let's say that you're trying to predict the price for a car, the price that a car will sell for. It might be based on many different features of that car, the body style, the brand, the mileage, who knows, how good the tires are. Some of those are going to be more important than others toward predicting the price of a car, but you want to take into account all of them at once. Okay, so fundamentally, it's still going to use the least squares approach to fit a model to your set of observations. The difference is that you're going to have a bunch of coefficients for each different feature that you have. So for example, the price model that we end up with might be a linear relationship of alpha, some constant, kind of like your y-intercept was, plus some coefficient of the mileage, plus some coefficient of the age, plus some coefficient of how many doors it has. And once you end up with those coefficients from least squares analysis, you can use that information to figure out, well, how important are each of these features to my model? So if I end up with a very small coefficient for something like the number of doors, that implies that the number of doors isn't that important, and maybe I should just remove it from my model entirely to keep it simpler, right? This is something that I really should say more often in this course. You always want to do the simplest thing that works in data science. Don't overcomplicate things, because it's usually the simple models that work the best. If you can find just the right amount of complexity but no more, that's usually the right model to go with. Anyway, those factors, those coefficients give you a way of actually saying, hey, some of these things are more important than others. Maybe I can discard some of these factors. Now I can still measure the quality of a fit with multivariate regression using R-squared. Works the same way. And one thing you need to assume when you're doing multivariate regression is that the factors themselves are not dependent on each other. And that's not always true, so sometimes you need to kind of keep that little caveat in the back of your head. So for example, in this model, we're going to assume that mileage and age of the car are not related, but in fact, they're actually probably pretty tightly related. So, that is a limitation of this technique, and it might not be capturing that effect at all, okay? So, fortunately, there's a stats model package available for Python that makes doing multivariate regression pretty easy. So let's just dive in and see how it works. All right, let's do some multivariate regression using Python. And we're going to use some real data here about car values from the Kelley Blue Book. So we're going to introduce a new package here called Pandas. And Pandas lets us deal with tabular data really easily. It lets us read in tables of data and rearrange them and modify them and slice them and dice them in different ways. So we're going to be using that a lot going forward. So we're going to import Pandas as PD, and PD has a read Excel function that we can use to go ahead and just read a Microsoft Excel spreadsheet from the web through HTTP. So pretty awesome capabilities of Pandas there. So I've gone ahead and hosted that file for you at my own domain. And if we run that, it will load it into what's called a data frame object that we're referring to as df. Now I can call head on this data frame to just show the first few lines of it. The actual data set is actually much larger. This is just the first few samples. So this is real data of, mileage, make, model, trim, type, doors, different options, the mileage, and the price that the car is valued at. Okay. Now we're going to use Pandas to split that up into the features that we care about. So what I'm going to try to do is create a model that tries to predict the price just based on the mileage, the model, and the number of doors, and nothing else. Okay. Now the problem that I run into is that the model is a text, like century for Buick. And everything needs to be a number when I'm doing this sort of analysis. So I use this categorical thing on pandas to actually convert the set of model names that it sees in the data frame into a set of numbers, a set of codes, okay? So I'm going to say my input for this model on the x-axis is mileage model converted to an ordinal value and the number of doors. And what I'm trying to predict on the y-axis is the price, okay? Now these two lines here just create a model that I'm calling est that uses ordinary least squares, OLS, and fits that using least squares, using the columns that I give it, mileage, model, and number of doors. And then I can use the summary call to actually print out what my model looks like. And you can see the R squared is pretty low. It's not that good of a model, really, but we can go down here and get some insight into what the various errors are. And interestingly, the lowest standard error is associated with the mileage. Now in the slides I said that the coefficient is a way of determining which items matter. And that's only true though if your input data is normalized, if everything's on the same scale of 0 to 1. If it's not, then these coefficients are kind of compensating for the scale of the data that it's seeing. So it's more, if you're not dealing with normalized data, as is this case, it's more useful to look at the standard errors. And in this case we can see that the mileage is actually the biggest factor of this particular model. Could we figure that out earlier? Well, we could have just done a little bit of slicing and dicing to figure out that the number of doors doesn't actually influence the price much at all. So if you were to run this little line here, we can say y, the price, group by the number of doors, and find the mean. A little bit of pandas syntax there. Pretty cool what you can do in Python in one line of code, huh? And that will print out a new data frame that shows the mean price for the given number of doors. So I can see the average 2-door car sells for actually more than the average 4-door car. So if anything, there's a negative correlation between number of doors and price, which is a little bit surprising. So this is a small data set though, so we can't read a whole lot of meaning into it, but as an activity, you can go ahead and mess around with the fake input data if you want. You can download that and mess around with the spreadsheet, read it from your local hard drive instead of from HTTP, and see what kind of differences you can have. Maybe you can fabricate a data set that has a different behavior and has a better model that fits it. Maybe you can make a wiser choice of features to base your model off of. So feel free to mess around with that, and let's move on. That's multivariate analysis and an example of it running there. And just as important as the concept of multivariate analysis is some of the stuff that we did in that Python notebook. So you might want to go back there and study exactly what's going on there. We introduced pandas and the way to work with pandas and data frame objects. It's a very powerful tool. We'll use it more in future lectures, but make sure you're starting to take notice of these things because these are going to be important techniques in Python for managing large amounts of data and organizing your data.